Hi, everyone. This is Allen from Ampere. I think this is the third day of Computex 2024, and I believe that there's a tons of innovation, new technologies that people are absolutely excited about it. And then when I was just walking in the Chamber's booth, more and more server ecosystem is moving toward to DCMS form factor, and having the NGX modules everywhere. So if you got time, welcome to visit Chambro because they got these two modules sitting right there, showcased to everyone. That's their solutions. And I also see that they actually not only have the official product, they also have the JDM OEM product there. So welcome to Chamber Booth. All right. Before I get into my topic today, I want to shout out to Chamber team because thank you. I mean, they are having me here to sit here to kind of share the message and also the innovation of the Ampere new technology here. So let me get into it. The topic today I want to share with you is data center modernization in the age of AI. So like I shared, in the recent 5 years, a lot of the new technology supplier, they have new products. They provide tons of cores, tons of PCIe lanes, tons of AI flops, tons of, storage data, right? But if you think about it in other ways, when you talk to your partners, your customers, they still need to focus on the capacity. Power, there's always the limitation of the power rack. I know that the current AI, deep learning rack, reach out to 50K watt, even 100K watt per rack. But you can see that the data centers, they actually need to put out rest of the power from the power drop. Normally, there's a 10K watt to 15K watt per rack in data center before. But right now, you can see that all the generative AI demand increased a lot. So that's the prices of the power and limitation we are seeing. Yeah. So capacity prices, right? Like I shared, most of the data center, they still have the power limitation. They have the space limitation. While the AI demand is increasing, people gonna start to facing this kind of problem. Because if we keep deploying, shipping like we are doing right now, it cannot sustain. So there's a 5 keynotes and a 5 bullet point I would like to share with you is, first of all, if you look at the data center research analysis, there's the production server on the line right now is actually 5 years old. On the line at the data center, most of server is actually like 5 years old. So first one is you need to think about the aging legacy infrastructure because costly, it's not utilized, and it's actually wastes a lot of valuable power, a lot of valuable spaces, right? So first one, think about facing the aging legacy infrastructure, especially with Chamber's chassis by more. Second is the constraint power capacity. Even you know that the AI deep learning right now is the first phase, but think about it. After 2 years, 3 years, people gonna move to the inference phase. At that time, you need more compute, you need more density. So at that time, you need to think about your power allocation, right? Second, the rising operation cost. It's actually echo the two bullet points I just mentioned. You have no power per rack. That means that you can only stand that rack in your data center. So think about how to have a utilized green data rack in your data center. Okay, so look at the right hand side. So it's a global data center energy consumption. 2022 is 460 terawatt hours. And after 2023, it's actually 590. And we are forecasting is until 2026, it reach out to 1,050 terawatt hours. So you might say, hey, Alan, what are you talking about? I don't have a feeling that 1,050 terawatt hour doesn't mean anything. Yeah, it means something. 1,050 terawatt wattage hours represent the whole country of Japan's power consumption. So this is the only data center power consumption. So you can imagine till 2026, the forecast is 1,050. So that means that the data center worldwide gonna consume power consumption like the whole Japan country. So this is absolutely the problems the end users, the partners that get not facing real quick, right? So let's think about that. How we can, while we want more cores, we want more memory bandwidth, we want more AI flux, we want more storages, but we still want to have a constraint power. We need to think about the spaces, right? So how you can do that? All right, now is the time. First, like I shared, refresh the aging legacy server, because I mean the legacy server has been a while. It's not utilized. You know, there's a tons of new technology, provide more cores, more densities, right? Second, reclaim the budget, the space, and the power. And the third is repurposes, right? To cloud native and also AI compute. Like I shared that right now, AI is at the deep learning phase. Everyone is having the huge AI, very power consumed AI server, deployment, shipping. But imagine at the end, the massive deployment will be the compute inferencing. That will be the key points that you need to notice. All right. And the very last one is actually the reinvest in innovation and sustainability. No matter what kind of the new technology you adopt, we need to notice the sustainability, right? So for those of you probably are not familiar what Ampere is doing or what we are offering to the ecosystem, next page, let me kind of give you a quick intro, right? All right, Ampere is a US-based company. We actually are offering the cloud native processors. You probably will ask me, why is cloud native, right? So our processor only, I mean, specific segment, which is server. It's tighter based on the cloud demand. It's born based on cloud demand. We don't do desktop, CPUs. We don't do CPUs for the AI PC. We are all focused on the cloud, focused on server, especially from the edge to the cloud. All right. And this picture show you that what is the difference between the legacy architectures compared with Ampere architecture. So you can take a look. The legacy architecture, they have multi-thread 5 core, while Ampere has a single core plus a single thread. It provides a constant operating efficiency. Imagine that everyone is all using Uber app, right? You call out the Uber car and you have a task, right? So one task will go to the regional data center of Uber. That's the first match because they gonna give you a first match for the car. That's the one task. So one task get into the one core and you have a dedicated thread right there. You don't have to having the legacy architecture, which is the shared threads. That means that we can have the more instant response to give you a first matchmaking. Second matchmaking is you got the call number, you got the money that how much you gonna spend. So the second matchmaking is the Uber app gonna matchmaking the credit card bank number that you would like to charge, right? Okay, that's the main difference between the other. Second is the legacy architecture have a limited code counts, limited power, but for Ampere we actually have maximum code counts. I'm gonna share with you some of our products later. And also, we have like every 30 to 40% less code power. We have advanced security features like memory takings. And while the legacy architecture actually has a smaller private cache, we have a large, lower latency private cache inside of the CPUs. This is Ampere's product roadmap. We actually have the first launch called Ampere Ultra Family. Is 4 years ago. It's up to 80 cores with TSMC 7 nanometer. The next year we have 120 cores, while the legacy architecture is still having 64 cores, or 50 cores. At 2021, we actually have 128 cores, 7 nanometer processors, right? And we actually just launched we call Ampere 1. The reason we highlight it as a 1 is we use Ampere customized core because, like I shared, we are the first cloud native processors provider. Our processor is tailored from the cloud. So we see that some of the features that's actually general available for most of the customers. But for cloud workloads, those features just will increase your power consumption. So we remove some of the features and we tailor it for the demands and the exactly features that cloud service provider needed. Last year, we launched a product called Ampere One family. The first one is actually up to 192 cores with 8-channel DDR, two memory, two memory slot per channel, and is each socket support 128 PCIe Gen 5, right? And later in Q3, we actually have later this year, we actually have a 12-channel version. That means that it still support up to 192 cores, but it's actually 12-channel memory. That's one thing per channel. So actually per socket, you can support up to 24 memories, right? And early of next year, actually, we having in the internal testing validation for the upcoming 226 cores. You have another socket infrastructure. So the board from the previous one cannot be leveraged, but we call this as MP1 family 2. So it support up to 256 cores. And the is actually still DDR5 PCIe Gen 5, and each socket support up to 128 PCIe Gen 2. And follow on, we actually have more and more families coming. And I just showed the kind of preliminary highlight and introduction of our products. Here's the, I should say, workloads or applications or devices that we use among our product roadmap, right? That's starting from the embedded devices. For previous customers' experience, some of the embedded devices actually they are working very good with the Ampere Ultra family, which just like from 32 to 64 cores. The amazing part why they're having consumption is from 40 to 75. It's very, very low power consumption, right? So it's actually good for the embedded devices. And second is the edge services, right? So like the AI factories, like the edge server, we actually have a mapping right there. It's 32 cores to 80 cores. The power consumption is from 40 to 190 wattage per units. So it's the energy efficiency one. Later on, we have two. I think the regional data center, right? It's a rack density. So there's a 64 to 128 cores available in the market right now. And the power consumption per node is actually 92, per CPU is 92, 180 watt. And very last one is actually the core data center. So it's absolutely the compute density required. So 96 cores to 192 cores. And the power consumption is from, 128 to 274 per CPU, right? Okay, I think that's the message. Actually, we want to leverage and deliver to the market and to the industry that while a lot of the new technologies provide a lot of good features, but when you talk to your partners, end users, no matter it's cloud service provider or even its enterprise customer, they would absolutely think about the space, the power, and also the allocation of the usage they're gonna use. So I think this is the presentation for today. Thank you for listening. Let me know if you got questions. Thank you.